All right, so today we're going to be learning about work problems. Work problems are problems that involve people doing stuff, like painting rooms, mowing lawns, or it can be pipes that are filling tanks or draining tanks, or things like that. So the formula we use is just the time together over their individual time plus the time together over the individual time for the second person equals one job. So if we use T for their time together, and I'm just going to use A and B for each of the people. So for example 1, Peter can mow the lawn in 40 minutes and Jamie can do it in 60 minutes. So 40 minutes that Peter takes, I'll let that be my A, and the 60 minutes that Jamie takes, that will be my B. And then their time together, how long, that's what I'm trying to find. Okay? So we just fill in the formula. I don't know their time together. Over 40 plus T over 60 equals one job. And then I use my lowest common denominator to do my fraction busting. So rather than worry about 40 and 60, what's a number that 4 and 6 can go into? A little bigger than 10. A little smaller than 20. 12, right? They all go into 12. So 120 would be my LCD, right? We just put the 0 back on. So I have to multiply everything by 120. And again, don't forget to multiply the right side where the 1 is, or that'll mess you up. All right, then I can reduce. So 40 goes into 123 times, and 60 goes into it 2 times. All right, so then after I reduce it, I'm left with 3T plus 2T equals 120. So you combine your like terms, 5T equals 120, and then we just divide by 5, and we get that the time is 24 minutes. Now, is that about what you would expect it to be? Does that answer make sense? Yeah, it makes sense, because if you had 2 Peters, how long would it take? 20 minutes. And if you had 2 Jamies, how long would it take? 30 minutes. So it should fall somewhere between 20 and 30 minutes, and it did. So that answer makes sense. Okay, but sometimes you might have more than 2 people, so you just add more fractions. The T on top is still their time together, and then A, B, and C are for the 3 people. So it says Jane, Paul, and Peter can finish painting the fence in 2 hours. So what does this 2 hours represent? It's all of them working together, isn't it?
Yeah.
Yeah, so that's going to be my T. That's their time together. And then Jane can do it in 5 hours, so we'll let her be A. And Paul can do it in 6 hours, we'll let him be B. And then how long for Peter, we don't know. C is a question mark. So their time together are 2 over 5 plus 2 over 6 plus 2 over C, or X, or whatever letter you want to use, equals 1. So now I've got to figure out my LCD. What will 5, 6, and C all go into? 30C, right. So now I multiply everything on top by 30C. And then, of course, on the right side also times 30C. All right, so why don't you guys try reducing that and solving the rest of the problem on your own. So after you reduced it, you should have had 12C plus 10C plus 60 equals 30C. All right, and then you combine your like terms, so we have 22C plus 60 equals 30C. I subtract the 22C from both sides. And now I have that 60 is equal to 8C. And so you just divide both sides by 8. And it comes out to 7 4/8, which you can reduce to 7.5. So 7.5 hours is how long it takes Peter to work alone. He's slow compared to the other two, right? Well, he is. He's slower than the other two. All right, now let's take a look at some pipes filling a tank. All right, tank A can be filled, the tank can be filled by pipe A in 3 hours and pipe B in 5 hours. How long will it take to be filled if both pipes are open? So why don't you guys try setting this one up yourselves and then solving it. Okay, so when you set it up, it should have been T over 3 plus T over 5 equals 1. 15 was the lowest common denominator, and you end up getting 1 7/8 hours. Sometimes you're going to have somebody who's working against you rather than for you, and when that happens, you have to subtract. So in example 4, Jane takes 2 hours to pick up her house, and it takes her kids 4 hours to completely destroy it. So they're working against her, right? And so how long if it's happening at the same time? So their time together is what I'm trying to find over Jane's 2 hours minus their time together over the kids destroying it in 4 hours. And that's going to equal 1 job. So this one, the LCD is pretty easy, right? It's going to be 4. So we multiply everything times 4. And then it reduces to 2t minus t is equal to 4. 2t minus t is just t. And so it turns out it takes 4 hours if they're both doing it at the same time. And the next one that's on your sheet is another one where something is working against it. Here we've got pipes and a drain. So 2 pipes are filling it up, and then 1 is draining it. And so we still just fill it in. We just subtract the pipe that's draining. So we don't know how many hours to fill up the tank. That's all together with them all going. So we're trying to find T. The first one does it in 3 hours. The second pipe does it in 5 hours. But the tank can drain it, or the drain can drain it in 4. So we subtract T over 4. So the LCD for 3, 5, and 4, they don't have any common factors, so you actually have to multiply them together. So what's 3 times 5 times 4? 60, yeah. So we're going to multiply everything times 60. And then we reduce it. So 3 goes into 60 20 times, 5 goes into 60 12 times, and 4 goes into 60 15 times. So we're left with 20t plus 12t minus 15t is equal to 60. So 20 and 12 is 32, and then when you subtract 15, you get 17t is equal to 60, and we divide by 17. So 17 goes into 63 times with a remainder of 9. So it will take 3 9/17 hours to fill it up.